Today I am going to discuss about semaphore. Semaphore gives the solution to the critical section problem for n number of processes. Okay, before that in the previous lectures we have discussed the two process solution. Okay, so what is semaphore? The semaphore is an integer variable. Okay, it is denoted by S. And when we want to solve the critical section problem, we initialize this semaphore variable S by 1. Okay, and this semaphore variable is used by the two atomic operations, like two primitive or atomic operations or functions like wait and signal. Okay, this wait variable, this wait function or wait operation will reduce the value of semaphore variable S by 1, and this signal operation will increase the value of semaphore variable by 1. Means this wait variable will reduce the value S equal to S minus 1, and this signal will increase the value S equal to S plus 1. Right. So how this wait and signal function will work? Let's see the definition of these two operations. Here we will pass the value of S in this wait operation, in this wait function, and in this it will check the while condition while S less than equal to 0. Okay, if the value of S is less than equal to 0, then do nothing, semicolon. Okay, if this condition is false, then S equal to S minus 1. It will reduce the value by 1. Right? And what the signal operation will do? Signal operation simply increase the value of S by 1. That is S equal to S plus 1. Okay. So what the wait and signal operation purpose is here? The purpose of both function is to solve the critical section problem for n number of processes. Okay, so we can understand this. Do wait S right, then critical section, then signal S. While okay, so here we can see that this wait operation acts as an entry section, and this signal operation acts as an exit section. Okay, so whenever process wants to enter in the critical section, first it will use the operation wait or this function wait, and after using this function it will enter in the critical section, and after coming out from the critical section it will use this signal operation. How this will work? Suppose S equal to 1 initially, right? So here in wait operation, the value of S will be passed as a parameter as 1. Okay, here the value of S is 1. Okay, suppose some process P0 want to enter in the critical section. Okay, so it will use this wait function. So value of S is passed as 1, and now it will check 1 is less than equal to 0? No. Okay, so condition is false. When the condition is false, then the process will come out from the while loop. Okay, and now the value of s will be decreased by 1, so here the value of s will be 0. Okay, so after resetting the value of s as 0, the process will enter in the critical section. Okay, some process p can enter in the critical section, or suppose p0 can enter in the critical section. Okay, when it will come out from the critical section, it will use this signal operation. What the signal operation will do? Signal operation simply increase the value of s by 1. Okay, here the value of s was 0. Now it again reset the value 0 plus 1 as 1. Okay, so this is the procedure of using the critical section for n number of processes. Okay, again, if the process want to enter the critical section, then it will check the value. It will check the wait operation. Okay, and then if the wait operation allow it to enter in the critical section, then the process will enter in the critical section. Okay, and after using this critical section, the process will come out. Here you can check the mutual exclusion also. If the process is in one process in critical section, then some other process can enter in the critical section or not. Okay, here you can check the progress also, and bounded wait, all three requirements. Okay, so these three requirements you can check yourself. Right. So till here we have discussed that semaphore is an integer variable that provides the solution for the critical section problem, and it uses this semaphore integer variable is used by the two atomic or primitive operations like wait and signal, and this is the definition for wait operation, and this is the definition for signal operation. In the entry section, wait function will work. In the exit section, the signal function will work. Okay, thank you.